So what is a chi-square test? A chi-square test is used to test whether two categorical variables are associated with each other. So an important distinction here compared to a lot of the other tests we'll be doing this semester are you need two categorical variables. And again, categorical like those buckets. You need male, female, non-binary would be a bucket. If you're asking someone's favorite color, blue, green, purple, those would be buckets. They must be categorical, and you don't want a lot of different options. You don't want like 100 buckets. You want a smaller number of buckets normally. As per our introduction, this is a non-parametric test. This means it does not need to assume normality, i.e. your data don't have to follow that typical bell-shaped curve, that normal distribution. You don't need normal data to run this test, which kind of makes sense because if you've got buckets don't really follow a bell-shaped curve. You probably just have some folks who like the color blue, some folks who like the color purple. It's not going to follow that perfect normal distribution. You don't need a normal distribution for this. I've left you some resources on the slide here as well if you need some additional help running a chi-square test. So I've linked to the U of G SPSS LibGuide where this video will eventually live. I've linked to the layered statistics guide because they give a pretty good overview. And I've also linked to the SPSS formal documentation, so their documentation of how do you run this test in the SPSS software. So really the only thing you need is two categorical variables. The assumptions of the chi-square test. Number one, you need two categorical variables. They need to be in those buckets. And number two, each categorical variable must contain two or more independent groups. So I'll say it again, two categorical variables, and those variables must contain two or more independent groups. You could have, for example, male and female participants. You could ask for their favorite color. Maybe it's blue, maybe it's green, maybe it's purple. What does this look like in SPSS? How do you set this up? In your SPSS, when we're checking these assumptions, we have to make sure we've set up our data properly so that we can run the test. Our first assumption is that you need two categorical variables. In our fake data set today, we're going to be using the gender variable and the color variable. So here we've got gender, you could be male or female, and we've got color, you might like pink, blue, green, or orange. This first assumption, two categorical variables, passes. Gender and color are both categorical. They have separate groups, separate buckets. Our second assumption is that our categorical variables need at least two independent groups. If we look at our gender variable here, in our fake data set, we have male participants and we have female participants. Within the gender category or the gender group, we have two different buckets. So two different independent groups. So the assumption passes for gender. And within color, we have four different buckets or categories. We have pink, blue, green, and orange. So our assumption passes for both of our two categorical variables because they each have two or more independent groups. You don't have both pink, blue, and green. You're either pink or blue or green or orange. Independent groups, you only get one of the options. How do you actually run the chi-square analysis? If you have the data set open in SPSS, you're welcome to follow along. If you don't have SPSS, or if you're just not feeling it today, you're welcome to just watch. You can always come back to the slides later. To open this on your own, or to run the chi-square test on your own, you would click Analyze, Descriptive Statistics, Crosstabs. So again, to run this on your own computer, Analyze, Descriptive Statistics, Crosstabs. That will open a dialog box that looks something like this. And what you do is you take your two categorical variables with independent groups, and you take them from the left side, and you put one of them where it says rows, and you put one of them where it says columns. And if you have set up the measure properly in variable view, the little symbol associated with your categorical groups should be either those three colored circles or those three colored bars. If you have a little yellow ruler, SPSS thinks you have scale data or continuous data, so you should back out of the dialog box, go to variable view, find this variable, and in the measure column, tell it you either have circles or you have bars. This is telling SPSS you've got a categorical variable. So again, if you've got a yellow ruler, that's a continuous variable. Your measure might not be set up properly, or you shouldn't be using that variable for this analysis. So you take your two different Variables that have 2 or more independent buckets, you put 1 on rows, you put 1 on columns. If you click the statistics button, it will pop out another little dialog box, and you want it to say chi-square. So you want to click the top left button. And you might also want to click the next 2 buttons on the left-hand side. One says contingency coefficient and one says phi and Kramer's V. We'll cover those in the output a little bit. But there's 3 buttons you want to check: chi-square, contingency coefficient, phi and Kramer's V. And then you'll click continue, and then you'll click OK. Oh, I lied. Don't click OK yet. Just click continue. We also want to click the cells button. When you click the cells button, it will pop open crosstab cell display as another dialog box. Here you want the top 2 left options. You want where it says counts observed and counts expected. And then you click continue. Once you've done those, make sure in the bottom left corner of the crosstabs dialog box, you've selected display clustered bar charts. So you've made some selections in statistics, you've made some selections where it says cells, and on the main page you've said display clustered bar charts, and then you're ready to click OK. If you have done those 3 little steps, technically it says 5 steps on the slide, but they're pretty easy steps, you'll get some output that looks like this. So let me grab my cursor. It's always a good idea to visualize the data to see what's going on. If you scroll to the very bottom of your output, I generally recommend doing this first. If you scroll to the bottom of your output, you'll get a graph that looks something like the one on my screen here. So we've got our male participants, we've got our female participants, and we've got essentially the count of each of these groups. Who likes which color? Who likes blue? Who likes pink? Who likes green? And who likes orange? And in our little fake data set, it looks like most of the females actually like blue. We've got 6 females who picked blue as their favorite, and we've got 5 males who picked pink as their favorite. So the graph is just a nice little visual to help you see what's going on with your data. If you scroll back up to the top of your spreadsheet, you'll see it says crosstabs because we've run the crosstabs procedure. The first table you get is called the case processing summary. It gives you your N, or your number of observations. Here we have 30 participants in our fake data set. And it says 100% valid. We've got no missing data. Every row was used in this specific observation or in this specific analysis. So that tells you your number of valid or missing data points. Our second table is the chi-square test table. Did I lie? No. Our second table, our first one is listed case processing summary. The second one is labeled based on the label that you used for your different groups. So mine says 0 equals male, 1 equals female, times, the star means times in SPSS, 1 equals blue, 2 equals pink, 3 equals green, 4 equals orange, cross tabulation. This is your cross tabulation table. So this will give you your counts. So how many participants said they were male and liked blue? How many participants said they were male and said they liked pink? How many participants said they were male and liked green? How many participants said they were male and liked orange? So it gives you the actual counts of who said what. And it also gives you your expected count. So the expected count is a calculation SPSS is doing behind the scenes to tell you what data did it think you were going to end up with. And in our case, it's actually giving some like half responses, which wouldn't make sense for our data set. You can't be half a participant. You can only be a full participant. So this is showing you your actual data, your observed data, and your expected data. And it gives you a little breakdown. The third table here is our chi-square test table. This table is going to show you the value of the Pearson chi-square test statistic. So it's like essentially a little x to the power of 2. That's your chi-square test. That would be the symbol we would use. It tells you the degrees of freedom for the test and the p-value associated with that test. Long story short, if your p-value, where it says asymptotic significance two-sided, that's your p-value, where it says Pearson chi-square, here it's 0.650. If your p-value is less than our golden threshold of 0.05, we would say there is a statistically significant association between the variables. So gender and color would be associated with each other. Here we have P is greater than 0.05, and we would say we failed to find a significant association between the variables. So I'll say that part again because this is kind of the meat and potatoes. It's the important part. If P is less than 0.05, these variables are statistically associated with each other. If P is greater than 0.05, which is what we have, we say we failed to find an association. And I see something in the chat. Let me go check. Ooh, I will come back to this one. Someone was asking me to rerun it. We have so much time, I will rerun it with you so that you know you're clicking the right boxes. And Heather says, how do we know what's expected for our second table here? So expected is a calculation that's happening behind the scenes. This is, if I'm remembering correctly, expected would be if there is an association, here's one way it might break down the data to say these variables are associated with each other. So the count is what you actually have in your data, and your count, here, I've actually got it on my next button here. If I click my button, there we go. So the actual count gives you the real breakdown of the data, whereas, and I think I've got that for the female participants as well. Yep, so that's the actual count of the data. The expected count is the calculation for, if I'm remembering correctly, if they are actually associated, here's one way we might break down the data to see that kind of association. In our case, the count and the expected count do not match. And that might be because our data is saying we failed to find an association. These variables are not associated with each other. If we played with the data, it's a fake data set. You can change the data, run it again. You could try doing something like, let's do a gender stereotype. Let's say all of the men really like blue and orange potentially, whereas all of the women really like pink and green. That might mean that they're associated with each other. And when you rerun the test, you might see your count and your expected count are different, and maybe then your p-value would be significant. Good questions, pals. So that's our chi-square test table. That's this third table. The Pearson chi-square line gives you the value, your chi-square value, your degree of freedom, and your p-value. If P is less than 0.05, you can say we found a significant association between gender and color. Here we found p-value is equal to 0.65, which is greater than 0.05, so we failed to find an association between gender and color. And our last table down here, I made you click a button that said phi and Kramer's V. This is our effect size. So you could use either phi or Kramer's V. These are essentially different effect sizes to say how big is this effect. A larger number would indicate a larger effect. Here we've got a value of 0.234, which is not a very large effect. We've actually got like a small or medium effect, depending what threshold you're using. And the significance, it says, again, that it's non-significant. So it's a small effect, it's a non-significant effect. We wouldn't actually generally report much going on here because we've got non-significant findings.